Plane Geometry and Similarity, a 7th grade lesson, Lesson 7, Intro to Similarity. So today we're going to talk about similarity. It's the word similar, things that are alike. So let's first start talking about the word congruent and what congruent figures are. Figures are congruent if they are both the same size. Whoops, let me get my pen going here. Same size and the same shape. So that means they are exactly alike, two things that are just alike. The ankle measures and the side lengths are exactly the same, but they do not have to be oriented the same way. So one could be upside down while the other one's on its side, and as long as they're the same size, same shape, and have the same angles, they're congruent. So let's determine in these four pieces if they are congruent or not, and we'll justify our reasoning as we go along. So, same size, same shape. Well, let's look at this. This is a square, this is a rectangle, so these are not the same shape. The next one, we have a 6 centimeter side, a 6 centimeter side, 9 and 8. We both know that they're both triangles, so they are the same size, they have the same shape to them, and the only thing is they are not oriented. They're pointed in the opposite directions. But yes, these are congruent. Okay? So in the next one, I can see right away they are both trapezoids, so they are the same shape. Same size, they need to have exactly the same side lengths. So we have a 5 and a 4 for bases. We have a 5 and a 4 for bases. Both sides over here are 3, so both sides are over here, so these are congruent. The next one I can see right away, they are the same shape, aren't they? They're both parallelograms. However, I can tell right away without even looking at the side lengths that they are not the same size. So this is 12 and this is 12. This is 5 and this is only 2. So that's a big difference. So this is not congruent. Now, this is different than similar figures. In order for figures to be similar, they must be the same shape. And the corresponding angles must be equal, or that wonderful word, congruent, which means exactly the same. And the corresponding side lengths must be proportional, meaning all the side lengths had to either be made bigger by the same number or smaller by the same number. So let's look at number 5. Number 5 down here, the corresponding angle to A, these are oriented different, is angle D. Angle B, which is the one with the right angle, corresponds to angle E. And remember, this symbol means angle, just to remind you of that. And angle C is obviously not the pointy one or the one. It's the same as angle F. So those correspond to each other. Side length AB, so here is AB, it's the pointy end to the right angle, is the same as D to E, DE, okay? And you can switch those around, but you want to stick with the same order that they used. Angle E is BC, so it's the short side, and BC starts at the right angle, so EF is going to be this side length. And then you have angle CA, CA, FD. Okay? So they're the same ones that if you were to take this guy and turn him, he'd sit right there and they would correspond. And that's what they mean by corresponding angles. Here's the word corresponding and corresponding side lengths. Now the next one is scale factor, and we did this way at the beginning when we did proportions, and we didn't call it scale factor. I did try to introduce the language a little bit, but scale factor is the ratio of, there's my O, of corresponding sides in a figure. So So the new over the original, 4 over 6. So we have the new one is here, the original. So it's a 4 to 6, 4 to 6. And what did we have to multiply by to get 4? Well, we had to make it 2/3. So the scale factor is 2/3. For figures to be similar, they must have the same ratio or scale factor. The shapes are labeled by corresponding angles, so they will start in the same point and go in the same direction around the shape. So we'll talk more about that. Let's put it in here. So rectangle GHIJ, so GHIJ, is enlarged to form KLMN. What is our scale factor? Well, let's look at this. What did 5 have to be multiplied by to get 20? Okay, so 20 divided by 5, it has a scale factor of 4. So you can either divide them out, and 10 divided by 2.5 is also 4. And I'll put that over here. 10 divided by 2.5 is also 4. In order for them to be similar, both sets of sides do have to have the same scale factor. And in this case, it does. So we have triangle EFG is reduced to form a triangle MNO. So our scale factor is, let's make the sides equal. So 6 to 3. So 6, we went from big. This has a scale factor. We went smaller, so I've got to do them the other way. We started, let me do it this way. We went from big to small. So we went half of 6 is 3. Half of 5 is 2.5. Half of 7 is 3.5. So if you look at all of these, if we put them in 2.5 and 5, and reduce all of those, they all reduce to 1/2. So the scale factor here is 1/2. So, based on questions 6 and 7, what do you notice about the scale factor of an enlargement? So if we're going from smaller to bigger, the scale factor was larger than 1. And when we go from bigger to smaller, we know that the scale factor was less than 1. And in number 9, let's look and see. Angle QRS is congruent to angle ZWX. So QRS is congruent to ZWX. So if you were to flip that and put it on it, or turn it, it is not. It is false. It would end up on this one right here. RS is the same as over XY. Those are congruent. ST is a side length. YZ is a side length. So that one was false. This one is true. Angle STQ is congruent to YZM. Let me erase this. So we have angle ST is the same, Q. So this angle right here is congruent to YZ. So is this one congruent to this one? Yes, it is. We just were to rotate it over, it would sit on top. And the last one here, ST over YZ, ST over YZ, and WZ and QT. And if you rotated that around again, it would be WZ and QT, ST and YZ. This one is also false. And these are false because